So, our first speaker, Valentina Porceddu, Head of RD Department at Mario Cucinella Architects, is specialized in sustainable integration design, with a solid research experience at different levels, supported by a strong multidisciplinary attitude. Born in Cagliari in 1989, she earned her bachelor in architecture at the University of Cagliari and her master architect with honor in sustainable architecture at the Polytechnical University of Turin. Since 2016, she is working at Mario Cucinella Architects, taking part to the National Adaptation Plan for Climate Change, the international competition for Taranto Oldo City, and the curatorial proposal for the Italian pavilion at the 16th International Architecture Exhibition of the Venice Biennale. Since 2017, she co-leads the course of Common Ground and provides tutorials and research supervision across the SOS program. Together, the RD department, Valentina supports the office within projects and international competitions at different scales, providing a holistic vision of sustainability and environment consulting that is the core business of MCI. Valentina, are you listening to us?
Yes, can you hear me?
Yeah, perfect. The stage is yours. Thank you.
Thank you. Okay, I will share my screen. Can you see my screen? I hope so. Okay, for the introduction, and of course, also for the invitation today. As said, I'm Valentina Porceddu. I'm the director of the Research and Development Unit of Mario Cucinella Architects, which is an architectural office based in Bologna and also in Milano, that involves a multicultural team of almost 100 professionals, including architects, engineers, designers, model makers, and of course also researchers. So our approach since the beginning, I'm talking about almost 30 years ago, has always been focused on how we can embed environmental design into our projects. And of course, if you look at the projects, no one looks the same. So because basically every architecture for us, it's deeply shaped by its context. Our founder, Mario Cucinella, usually talks about creative empathy, which is the kind of relationship that building seeks with its environment. And among our recent experiences, there is also TECLA. TECLA is, I think, a well-known project, and the name stands for technology and clay. The project itself, it's rooted in a research phase carried out by the students of School of Sustainability, which is a postgraduate course that runs in parallel with the activity of the office. But the final materialization of the project is the result of the combined effort between MCA for architecture and WASP for 3D printing. But the whole process also included a number of Italian-based firms for other aspects, such as furniture, mixed design of the soil to be printed, and so on. TECLA, it's also inspired by Italo Calvino's Invisible Cities, because in the book, TECLA is the city undergoing a continuous construction process. And dear to us, it's also the concept of combining together the past and the present. So the past meaning vernacular knowledge, vernacular architecture, natural and local material like raw earth, together with what is new. So basically technology and in this case, 3D printing and additive manufacturing, that it's for sure one of the disruptive technology of the 21st century. So the story I'm going to tell you today is basically starts from our initial assumptions and the context in which we move in, the research phase, and finally the realization of the first prototype built in Massa Lombarda near Bologna. So first of all, for sure, the challenges. So today, one of the most urgent challenges is climate change, as we all know, I think. Of course, 3D printing in general and also TECLA try to give a partial answer to this challenge, focusing on some aspects, and specifically in our case on the kind of material used for printing on one side, and on the other side, using 3D printing and exploiting its benefit in reducing the construction waste material. As you can see from the pie chart in the middle of this slide, the construction sectors alone accounts for a huge part of the global greenhouse gases emissions globally produced by all the sectors, almost the 40%. And of course, this is reflected in the trends in rising temperatures. But as architects, we tend to frame the issue of sustainability always or often in terms of efficiency. So we focus most of the time on the operational phase, which is good, but maybe it's not enough. So we don't need just to design and realize building that consume less, but also pay attention to the whole life cycle of an architecture. So considering first of all the material production, the components production, the construction phase until the end of life. So what kind of end of life scenario we can imagine for our buildings. And there's then another challenge, which is of course also the increase of population and the demographic trends that will result for sure in an increased housing demand. And this housing demand and the demographic trends are, of course, not evenly distributed all over the world. We know that for sure will hit mainly the south part of the world. And yes, one solution we have for sure is redeveloping existing buildings, but new buildings will still exist. And we have to try to think about alternatives in the way we design and deliver our construction. So we feel the need with this project to deepen and to explore a bit more how new technologies might be helpful in tackling those issues. So 3D printing, again, for us, it's not the all-in-one solution, but it's for sure a topic worth an exploration and a research. So it's full of data, of course, about benefits of this technology. But I like to remember always a sentence by Cedric Price that once said that, okay, technology is the answer or might be the answer, but sometimes we forget what was the question. So for instance, it's true that especially if it will be consolidated over time, 3D printing will allow to construct in shorter times. But we need for sure to ask ourselves, okay, shorter times for what? For feeding the urban sprawl, or for instance, trying to find an answer for emergency context. And this is one topic. Another one is that we have to lower the cost. So we need to probably combine 3D printing with other emerging technology and other kind of knowledge, especially trying to embed into 3D printing standardization, and in order to make dual-links and every kind of architecture affordable for people. And lastly, also emissions, and not just the emissions produced to operate a building, but also emissions produced for material again. So there are a lot of projects all over the world that use, for instance, a lot of cement for 3D printing, but this is just a new way to do all things. And that's why we decided to focus on raw earth. And basically the mix that constitutes TECLA is of course made of raw soil, local soil, combined together with water. with fibers coming from agricultural waste in the region near the Po Valley. And of course, also an additive that was developed by Mapei, another Italian company located near Bologna, that of course still contains a small amount of cement, but we are talking about the 5% of the whole mix. So basically the research is trying to go on in developing more sustainable solution. And this of course requires efforts put in place time by time. So going through the research, we particularly appreciate vernacular architecture inspiration, because in vernacular architecture, beauty is not randomly conceived. It is always the result of an awareness about structural needs, environmental needs, and technical needs more in general. And we decide to focus on the dome, which is an archetypical shape of vernacular architecture, both for structural reasons that are well combined with 3D printing, but also because it's important also to consider the feeling of the final user. So for instance, every time our founder describes TECLA, he always say, this is like a welcoming belly made of raw heart that embraces the final user. So it's important also to consider the feeling in the final user. Did you see here are the small scale prototypes developed together with WASP while we were in the middle of the design process. So as you can see, TECLA was conceived as two domes connected together by this continuous sine curve culminating in the skylight. And together with these material experiments, we also use, of course, also software simulation. And in particular, this one is a simulation made by Milan Ingegneria, that was our structural consultant, because we want to be sure that this shape is not just randomly conceived, it's something which is consistent from an aesthetic and also a functional point of view. And focusing on one aspect of the architecture, which is the infill, the envelope of the building. This was an interesting idea developed by the students of our postgraduate master. So the envelope was constituted by this kind of double sine curve, in which you can see that multiple functions, multiple performances are provided. So the internal layer provides both thermal insulation to avoid too many heat losses, and thermal inertia that is particularly helpful, especially in summer. While the external layer, the external curve, provides both self-shading to the building, which is useful to control direct solar radiation, and also in-field ventilation. The idea, which is for sure interesting and needs to be further explored, is we can maybe play with density and the thickness of the sine curve and the envelope in order to meet the needs of architecture at different latitudes. Because, for instance, thermal insulation is not always needed and not always in the same way, and the same for thermal inertia and so on. Of course, you need to pay attention also to the soil characteristic, because it's true that soil is widely available, but it's also true that not every soil is suitable for construction. So if you need if you have the soil on site, but it needs too much additives, maybe it's not the right technology. And together with developing these, let's say, infill alternatives, we were able also, together with the students, to perform some thermal simulation together with the softwares and other tools we have within the office. So moving to the prototype, the idea behind this residential unit is to try to create a family of solutions, not just a solution, even if we came up, of course, printing just one prototype. But the idea is wider. So all the solutions in the family share the same principle, namely merging together past and future. So vernacular architecture and this dome shape with some openings, of course, together with 3D printing. But these shapes is slightly changed according to the specific location, together with the position and the dimension of the openings and the characteristic of the envelope. And another important point is that printing raw earth is challenging also because, and printing in general architecture is challenging because it requires to rethink and revolutionize the whole process, the whole design process. So we work together side by side with MAPI for the mixed design and WASP for 3D printing without in total continuity. So it was not a classical or business as usual approach. And with a special attention to the raw materials, of course, you need first of all to think where and for whom. So to understand the climate, to understand the materials and natural materials, especially that are available, and then starting to prototype in order to custom the envelope, the shape of the building at the architectural scale, and also the logics and the rules behind the aggregation of multiple models in the case you want to deliver a whole master plan. So all the typologies we thought about shared again the idea of the dome, which is particularly interesting because it allows us to avoid the use of formworks that might be an obstacle for the 3D printing machine, and of course the openings. But the position of the openings and the shape of the buildings is slightly changed according to the context in order to really meet the condition of each site. So for instance, in cold climates, the best strategies is to look for compactness because you need to avoid as much as you can heat losses. And on a master plan scale, it's important also to provide a mutual protection between the dwellings from cold winds. And this is possible by arranging the individual housing units closer together and leaving at the center these small comfort pockets that are protected from cold winds. Moving to the architectural scale, we can see that how the opening is moved to the south exposition in order to catch the sun rays, which are particularly lower in these locations, and also to try to exploit as much as possible the heat given by the sun, which is of course not so much. On the other side, on the neck of the building and also on top, we have a more opaque envelope because we have considering the north side to provide protection from winds and considering the roof, help the roof in bearing the load of snow. And this is a kind of quick visualization of the final result. Then we move to the humid climates. In humid climates, the principle is the contrary. So you need to keep the dwellings to give more space among the units in order to enhance permeability, which is the best strategy because we don't have huge thermal daily swings. So we cannot rely totally on thermal inertia because it's not a suitable strategy. So we need to promote ventilation. And this is true also at the architectural scale. And that's why we decide to imagine to open more doors and windows all over the perimeter of the prototype, the ideal prototype in this case, and also to stretch a bit the dome in order to promote two mechanisms of ventilation, which is cross ventilation and ventilation by stack effect. And this is more or less the idea and the aesthetic. And in arid climates, communities are instead tend to seek comfort going downwards into the ground because they want to exploit the thermal inertia and also because it's possible in this way, going downwards, to provide protection from sandstorm and also to collect rainwater, which is precious. And of course, it doesn't rain so often. So it's important to not just provide shelter, but also to think about other resources that might be helpful during the life within this unit. Moving on the architectural scale, we can see how there is this mechanism of thermal inertia thanks to which the ground and the house exchange heat gradually, moving from night to day. And also we have the creation of this kind of patios, thanks to which the fronts of the building are mutually shaded. And these allow to create this kind of environment, which is a kind of small oasis, a kind of treasure within the desert. And then we have maybe, at least for me, the most challenging climate, because represent basically an average condition of the previous ones. So it's not easy to find an interpretation which is clear. So it's necessary to balance conflicting needs. So to balance heat loads and heat losses, to protect from winds on one side, but also to favor permeability. And this, of course, changes a lot according to the location, at least in Italy. So this is a kind of average typology compared to the other, because we have both openings on the perimeter that needs to be shaded, of course, the window to wall ratio, so the amount of glazing compared to the opaque components needs to be weighted. And we have, of course, also opening on the top. So we have skylights equipped with movable shading, because sometimes we want solar radiation, sometimes not. And this is the final image before starting to print the prototype. As you can see, it's not a huge prototype. It's an housing unit of around 45 square meters of net area. The layout is arranged in a way in which we can have two main rooms: the living room equipped with a kitchen, and the bedroom with services. And also the furniture is important. As you can see, with this organic shape, it's not easy to provide furniture. And that's why we have collaborated with local firms in order to also exploit the potential of CNC and parametric design, and try to develop more knowledge also for that sector. Here, a render of the prototype in a night view. So the skylight is completely open because we don't have the sun, of course, and the issue related to the sun. And also because in this way, people can look at the stars. And during the day, we can decide according to the period, according to the needs, to activate the shading system. So the light inside the building is more diffuse. And this is something related to what I was talking about before. So we need to combine this organic shape. The real challenge is to combine this organic shape together with standardization. For instance, at the moment, we are reflecting a lot on how we can focus more on the window frames, because we would like to design something that seems irregular, but is actually suitable for installing standard frames already available on the market, because this has a side effect on, of course, also the affordability of this unit. And here you see a progressive section of the envelope going from the bottom of the building to the top. As you can see, how it reflects basically the result of a solar radiation analysis. So the external layer is more dense, where shading is more needed. Here, a really quick section showing the bioclimatic principle of this project. So first of all, of course, the skin and this roughness, which is motivated by the relationship with the sun. And thanks to Grasshopper and other kind of parametric software, we are able to remap the values of the solar radiation all over the envelope in order to create a responsive skin. The shading system for the skylight, and of course also always with the Grasshopper or other tools, we are able to control and always establishing a dialogue with our consultants for mixed design and for structures. They control the slope of the envelope, because we want to promote as much as we can water drainage first of all with the shape of the building, then thinking about the mix, and then so on with other kind of elements that can be embedded into architecture. And we have the envelope. The envelope was insulated with the rice husk, which is another byproduct of agriculture, which is typical of the Po Valley here in Italy. So it's something that would be waste if not used as insulation. And it's all inside this idea of creating a circular economy around the prototype. Here you see the kind of a scheme illustrating the kind of printing machine we used, thanks to WASP. There are basically two main families of 3D printing machine. One is the Cartesian, so printing machine where there are two axes of movement, the X and Y axis, and this one, which is the delta, where you have one or multiple arms moving on polar coordinates. And this gives you freedom to design these kind of complex shapes. Here are a close-up on the envelope during the process, and here you can see the prototype during the construction process. So looking at the prototype from the above, you can see how basically each arm of the printing machine is able to print an area of around 50 square meters. And then to conclude, so I think we will have time for questions. Some data about the project. Again, it is a small unit of 45 square meters, and that required 60 cubic meter of soil. The printing time was around 200 hours, and the consumption, the electric consumption for the construction was negligible, and compared to what is the standard in the construction industry. And obviously, it's better if you're able to, as in this case, to cover this consumption from renewable sources. So thank you.
So thank you, Valentina, for your great presentation. We're going to move on for some questions in the audience. So here in the room, does anyone want to place some questions to Valentina about the concept, the system? No? Everyone is very shy? Here,
yeah,
in the first row. Just a moment for the microphone.
Thank you. Thank you for the nice presentation. I have a question that is not technical, because I think the project you've shown is very clear, it's brilliant, it's beautiful. But when you were talking about it, I was wondering, because you're proposing a very flexible system that adapts to climate, and this is a technical part to it. So temperature, latitude and all these things. But then there is culture as a second component. And looking at these things, I was wondering, okay, how are these cultures, that would be the recipient, I mean, in a very logical and reasonable, world of this beautiful architecture, perceive them? And I was reminded 20 years ago in India, the father of a friend, an Indian architect, doing very nice sort of regional modernism, so working with climate and all this thing, said the biggest problem there that he wasn't find client, because as soon as you were going up to the middle class, not even talking about rich, the role models would be glass and climate control and all these nice things. So what you're proposing could, in worst case, be perceived as, colonialism, and the worst case just doesn't work, But now, what I think, and this would be the question, how, maybe there something in there, and this is the 3D printing, and this is actually the high tech that could again make it attractive. It's sort of a double, spin. You know what I mean? Because I think if you are not able to communicate that these things are actually not just regressive, you know, go back into your earthen caverns, you know, but this is really high tech. This is the most, you know, attractive thing you could ever buy, you know, and probably make it also expensive, you know, in order to create sort of role models for this. You know, it's fully speculative, but I think there is a problem there, you know, between the beauty, the vernacular, and the reality of, you know, 90% of the planet.
Thank you for the question. I think I'm totally in line with your comment because, as I said during the presentation, yes, technology is the answer, but sometimes we forget what was the question, no? And yes, it's a matter of culture. Of course, during developing TECLA, we were focused on some of the issues or opportunities of this technology because we were fascinated by the idea that maybe we can improve a bit the trend about 3D printing in architecture as we see around us. So there are many printing architecture with cement, but not just cement. It's also about the process and the idea behind these buildings. No, they are just whole buildings printed, but basically it's the same kind of architecture, just done in a. And of course, during our experience with TECLA that last more or less 1 year, we were able to approach just part of those issues. But I totally agree with what you were saying. So when we are receiving many requests, but of course it's difficult also to move from the prototyping phase to the market. There are a lot of other passages to be done. You have also to think about the communities receiving those kind of prototypes. Not receiving, because it's not good to say you are sending something for them. You need to create an architecture that can be really absorbed or construct together with people. So we didn't have the opportunity, but it would be amazing for us also to challenge the kind of architectural shape we conceived, because it's not just a shape. That shape affects a lot of other aspects. So trying to establish a dialogue with local communities would give us the opportunity, for instance, to moving from printing the wall prototype to print maybe small models, because maybe it's closer to what some communities do or have done in their past. So there are ways, but again, the purpose in our case was just to explore the potential of this technology, because at least for me, until you put your hands into the project, you don't understand, but there are a lot of constraints, a lot of advantages also. But yes, for sure, it affects many aspects of the projects, not just the technical one, as you said, but also the supply chain, for instance. It's not the traditional way in which we design and deliver buildings. And one of the points is for sure also how we can involve communities, because most of the time when we talk about what is called open source architecture and 3D printing is part of this thought of this thinking, there is the idea that okay, you can give a printer to people and they just print. But yes, there's something more behind that still be investigated. So just to end with my answer, I have not the answer, but I'm aware of the topic, and in our internal discussion, we also came up with the idea that maybe we can challenge the shape we came up with this project in order to be more flexible for other kind of contexts. Why not?
Thank you. Any more questions here in the audience? No? So maybe continuing this discussion about shape, obviously your project has a very specific aesthetic that is perfectly fine, but my question is, do you think this could adapt to different shapes, or is it very connected, the shape you did with the technology? Is it a technical limitation? Because, for instance, I would love a window in the house, you know, and you don't have any. So is this the beginning of the future of the technology that can adapt to well, common shapes maybe, or more flexible shapes?
Yeah, for sure. And well, I can't talk a lot about this, unfortunately, but we're currently investigating in another project, always dealing with 3D printing and art. This topic specifically, the topic of windows, because there are plenty of solutions in also vernacular architecture to create openings in the wall without too many helpful other accessories or tools. So the point is that there are many challenges. First of all, if you want to create something which is not conventional, but not because you want to deliver something which is simply strange, but because beauty is also part of our job. There are many ways. The point is, again, you have always, when you design, you have always to think at the same time to the printer, and you are already printing behind the building. So it's important to understand. Okay, I can and managing this in a pretty clever way. You are able to create a formwork for the openings without making an obstacle for the printer machine, because the printer machine is the mean, it's not the final aim of the project. The final aim of your project should be to have windows. So not to help the printer machine. And there are many solutions. We are collaborating, for instance, with a firm that is able to use folded formworks that can stay into the building. So you are able to place a lintel that can be folded while building. There are inflatable solutions, so inflatable formworks that can easily appear and disappear. There are many ways. Also a way in which you have to think about combining together, for instance, 3D printed walls and panels, other panels, also prefab panels, something or printed or that exploits CNC, in order to save this idea of a smooth shape, but at the same time using standard frames. Because otherwise, if the window frame costs the house, it's not affordable. So yes, there is a lot. Just the window frames require 1 year of research.
Thank you.
But we are doing.
Any more questions here? Yeah, we have one question there.
First of all, I would like to thank you for the presentation. I have a more technical question. For example, in the project Milestone by the University of Eindhoven, they are printing with concrete, and they still have to use like some steel elements to hold the walls, like the two faces of the walls. And my question is, have you overcome that obstacle, or because that would mean that you need to have more manual labor in the construction process, and that like is a contradiction, I think.
Yes, basically also the sine curve you saw in the presentation was meant also to provide solidarity among the internal and external layer. You see, the design of the wall is not random. It's also meant to try to tackle this issue, because yes, as you said, if you're printing the internal and external layers, and then you need someone to put, I don't know, a steel element into the wall, it's not a huge difference. Like I was saying before, it's like old buildings with the new technology, but it's the same. So yes, and that's why you use the sine curve. But it's challenging because it's when you design the sine curve, then you have to start doing a mock-up. And actually, before TECLA, we have done some mock-ups, also real scale mock-ups of a slice of the building to better understand if the mixed design is suitable to provide the right strengths for the sine curve. So every time we need to readapt the sine curve to the mixed design, it requires a bit of work. So it's something in the middle between customization and standardization. That's not there is not the all-in-one strategy. It's more an average. It's more a fine-tuning work, at least at this stage. But I believe we are in a phase of exploration, but 3D printed in architecture is not, at the moment, generally speaking, not about us, but all over the world. I think there is still a lot of work to be done. Research is also failure, 99 failure. So we'll try to
Thank you, Valentina.
tackle to this problem.
More questions in the room? There?
Yeah.
Thank you so much for the presentation. I really liked how you show that 3D printing, I guess, which is often understood as a miracle technology from Star Trek that just generates shapes no matter what's happening with the shapes themselves or the material. It actually is not like that. It has an effect on the design, on the design geometry and on the final textures. So thinking of this, I was wondering, you kind of mentioned it, but you didn't go into detail, so I don't know if you explored this. Many 3D printed objects, depending on the type of printer, have support structures, support sprues. And also sometimes, depending on the algorithm of the support sprues, sometimes these supports are really beautiful. When we prototype things, we often think that we don't want to remove the supports, or we want to start designing with the supports. So I was wondering if instead of just trying to keep such a pure dome shape, if you ever tried anything with support structures that are part of the design and also help you, of course, make the whole thing stand.
Thank you for the question. Well, of course, with the dome, if we decide to use the support, it would be a bit strange because you start from something that is stable for definition, even if the dome you've seen is not a classical one. But again, it's a matter of parametric design and analysis at the same time. So in that case, we didn't think about support. Now we are starting to work with other kind of shapes. And as I said before, for instance, for the openings, for us, the support is needed in order to create the openings on the perimeter. So we are doing a step forward compared to the previous research phase. But we were thinking, okay, can we embed this support into the design? So it's not just a formwork, it's something which is that really characterize the aesthetic of the building. And hopefully there are plenty of examples in our culture and in all over the world, of course, of those kind of strategies. For instance, the idea of the dome from a structural point of view, of course, not exactly in that way, but if you think about the dome of the Pantheon in Rome, it's a dome with a gradient in its density, no? And this is the same kind of effect that is done with the envelope of TECLA, because the sine curve, the number and the density of the sine curve change when you go from the bottom part to the top. Yeah, so we are definitely interested in understanding. We don't want to just say, okay, we don't need support. It was for the previous project because we were exploring the shape of the dome. But at the moment, we are also interested if we can use support in a clever way, and supports are helpful to make the project more suitable for a wider community, more affordable, more with more openings on the perimeter, and why not? If of course we need to find as architects a motivation with that is not just structural. It's more complex. In a way in which the supports participate to the complexity of the architecture. We are really exploring this topic.
Thank you, Veronica.
Questions?
So, any last questions? No?
I don't think.
Yeah, I think online.
Online, no?
So, Veronica, thank you very much for being here with us
Thank
and
you.
to participate in the
Thank
event.
you very much.
And we hope to see you soon in Porto.
Why not? Other times, but I hope so.
Thank you.
Bye.
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 Thank you.